Hey everybody, let's look at this one from 1978. This problem is as old as I am. So it says we got a block of mass M, M1 it actually looks like there, I don't have it there. Actually, let's add that too here, that's important. A block of mass M1 travels horizontally with a speed V0 on a plateau of height H here until it comes to a cliff. A toboggan of mass M2 is positioned on the level ground below, as shown above. The center of the toboggan is a distance d away from the base of the cliff. So determine this distance d. So the block's going to go do like that. It's a horizontal projectile. Determine that distance d in terms of v0, h, and g so that the block lands in the center of the toboggan there. So this is just a horizontal projectile problem. We've done many of these before. Remember, always start with the third kinematic equation in the y form. So the delta y is equal to the v0y times t plus 1/2 times the y acceleration, which is g times t squared. There is no initial y velocity on a horizontal projectile, so we can write that the time is equal to the square root of 2 delta y, but delta y here they're calling h over g. All of that underneath the square root there. So now let's figure out d here. So let's do the third equation. Again, delta x is equal to v0x times t plus 1/2 times ax times t squared. Well, there is no x acceleration, and so that drops out right there. And so the last part then that we got to do is simply to do this. The delta x they are calling d. This velocity here is the velocity they just straight up gave us, v0, and the time is the time we have right here, which is square root of 2h over g. And there we go. That is it. So now we're ready to move on to the next part. This block is going to collide with the toboggan, and it is going to create a conservation of momentum problem. Now, by the way, let me scooch this down a little bit here to show one thing that's going on here. Let's say that this is the sled right here, and as the block comes in, it has got a velocity that looks like this because it's a horizontal projectile. So what do we do about that? How do we handle that conservation of momentum? Well, horizontally, this is the only velocity we need to worry about because there are no forces, there's snow, there's no friction, so there's no outside forces, no outside impulses. Momentum's going to be conserved in the x direction. However, in the y direction, there is going to be an outside force, the normal force. So y momentum's not going to be conserved. It's going to stop this thing. But we don't need to worry about the y. We can solve this like a normal conservation of momentum problem just by focusing on the x there. So let's set it up like we normally do. The momentum of the system beforehand is equal to the momentum of the system afterwards. Now, when we're first moving, we got the momentum of block 1 up on top of the hill, and afterwards we got the momentum of block 1 and 2 are combined afterwards. So now, momentum of object 1 before is m1 times v0. It's just simply mass times velocity, and afterwards we're going to have a combined mass of m1 plus m2, because the block is stuck in the toboggan, times some unknown speed here. And so then last step here is we just solve for our velocity afterwards by dividing this whole term to the other side. So we get m1 times v0 over top of m1 plus m2. And that is it for this one. Whoops, sorry, hold on. Look, there it is. I scooched it out of the screen. So there's the final answer.